guys, in this video we're going to talk about solving quadratic equations using square roots. It says part 1 because there's kind of two different parts to solving square roots, and we're just going to focus on the first part here because it's SAT week and it's really short. So um, square roots for many of you will be much more intuitive. It's going to remind you a lot of Algebra 1 in parts of it. So if you were strong with Algebra 1, this might be much more comfortable to you than the factoring in the last unit was. So quadratic equations can come in three different forms. We've talked a lot about standard form, how it's ax squared plus bx plus c equals 0. We've also worked on moving that standard form into a factored form to make it solvable. And then now we're going to talk a little bit about vertex form. So vertex form is a times x minus h squared plus k equals 0. All three forms have pros and cons, and as we move throughout this unit, we're going to refer to all three of these forms. So in order to solve using square roots, it's really important that you know your perfect squares. We've reviewed this towards the beginning of this year, but here's just another review chart in case you need to take a screenshot or a picture with your phone so you can refer back to this later. So to review, to simplify a square root, you need to find the biggest perfect square that goes into that square root. The biggest perfect square that divides evenly into that square root. So for instance, in the first example, I know the square root of 49 is 7. Clean and simple. In the second one, the largest perfect square that divides evenly into 250 is 25, goes in there 10 times. So I get 5 radical 10. This third example, though, you might not know what the biggest perfect square is that goes into 245. If you don't know, you're going to want to start dividing out until one of those perfect squares divides in evenly. In this case, 49 goes in here 5 times. And so it simplifies down to 7 radical 5. This last example, the 9 is your coefficient. It's what's multiplying by the square root of 45. So I know the square root of 45, the biggest perfect square that goes in there is 9 5 times. So really I have 9 times the square root of 9 is 3 times the square root of 5. So my final simplified answer would be 27 radical 5. So we didn't review this at the beginning of the year. Wasn't really necessary for the work we were doing, but you can simplify a square root if you have a fraction within it. So really what happens, if you have the square root of a over b, it's simply the square root of a over the square root of b. So in this case, the square root of 25 over the square root of 4 is 5 over 2. The second example, the square root of 3 over the square root of 25. Well, I don't know the square root of 3, and there's no perfect square that divides into 3 evenly other than 1. But I know the square root of 25 is 5. So this is completely simplified. This is completely simplified. Let's look at this last example. So the square root of 25 is 5. Again, square root of 3 cannot cleanly be simplified. But if you remember from geometry, you should never leave a radical in the denominator. Moving this radical to the numerator is called rationalizing, much like getting an imaginary number out of a denominator was called rationalizing for complex numbers. So 5 times radical 3 is 5 radical 3. And radical 3 times radical 3 is really radical 9. So we get 5 radical 3 over 3. notice radical 3 times radical 3 is just 3. Another way you could prove this is using, not with that, using properties we learned earlier this year. It's really like 3 to the 1/2 times 3 to the 1/2 is 3 to the first. Any strategy you use, you end up with 3 in the denominator. So that was just reviewing how to simplify a square root. It's important because in all of these examples to come, you're going to need to make sure your final solution is completely simplified. So let's look at this example. If you go back to Algebra 1, you learned that to isolate a variable, you needed to move both the constant and the coefficient. Remember, a constant is this number with no variable attached, and a coefficient is the number that is being multiplied by a variable. So in this problem, my first step is to subtract 1, and my second step is to divide by 8. So I get x squared equals 2. And then the opposite of squaring something is taking the square root. So I end up with x equals both positive and negative radical 2. So that's just the shorthand way of saying square root of 2 and the square root of negative 2. The reason it's important to keep that negative in there is because if you don't, you've lost the solution. But also from a logical standpoint, whether I plug in radical 2 for x or I plug in negative radical 2 for x, either way, I get 17. Because that value, the radical 2 and the negative radical 2, are being squared, they both become positive. So your final answer is x equals plus or minus radical 2. Next problem. So on this one, I'm going to start by moving my constant. The opposite of subtracting 9 is adding 9. Then I'm going to divide by 2. And then I need to figure out, when I go to take the square root of both sides, I end up saying x equals plus or minus radical 32. I know the biggest perfect square that goes into 32 is 16, and 16 goes in there twice. So my final answer is x equals plus or minus 4 radical 2. So in this example, I'm going to start by subtracting 3, and 111 minus 3 gives you 108, and 108 divided by 9 gives you 12. So I get x squared equals 12. And then when I take the square root of both sides, the biggest perfect square that goes into 12 is 4. 4 goes in there 3 times. Square root of 4 is 2. Radical 3 is not a clean integer. So my final answer is x equals plus or minus 2 radical 3. So all of these solutions we found are called exact answers. Leaving that radical in there gives you an exact answer. If you were to be silly and get out a calculator unnecessarily, the answer you get would be an approximate answer unless your end answer was a clean integer. So on this one, I'm going to start by adding 75. 225 plus 75 is 300. And then 300 divided by 5 is 60. So now I'm going to take the square root of both sides. And I have to figure out the biggest perfect square that goes into 60, which is 4, goes in there 15 times. So my answer is x equals plus or minus 2 radical 15. Next problem. So on this one, again, my constant is this number over here that has no coefficient. So to get rid of that, I'm going to subtract 4 from both sides. I get negative 3x equals negative 81. Then I'm going to divide both sides by negative 3, and I know that 81 divided by 3 is 27. So I get x equals 27. X squared equals 27. Then when I take the square root of both sides, I get x equals plus or minus 9 radical 3. Sorry, radical 9 radical 3. So the final answer is plus or minus 3 radical 3. In this example, I'm going to start by subtracting 1, negative 40. And the opposite of multiplying by negative a half is multiplying by negative 2. So I end up with x squared equals 80. And the biggest perfect square that goes into 80 is 16. Goes in there 5 times. So that tells me that x equals plus or minus 4 radical 5. Next example. I'm going to subtract 5 from both sides. Get 81x squared equals 16. 16 divided by 81. Well, that does not appear to be a nice clean number. But when I go to take the square root, using what we reviewed earlier, I know that the square root of 16 is 4, and the square root of 81 is 9. So I get x equals plus or minus 4 ninths. So these next couple examples are going to look and feel a little different, but we're really applying the same rules as we've been. We're going to get rid of our constant and then our coefficient. So we're going to subtract 15. Gets us negative 12. And we're going to divide by negative 2. Then the squared part is my outermost function once I get here. So when I take the square root, I get x minus 3 equals plus or minus radical 6. And you should always look at that number in its radical to see if it can be simplified. In this case, it cannot. So now that I'm left on, I'm going to move over here. I'm going to add my 3 over to isolate that x. And the rule of thumb here is your integer number is always going to be in front of the plus or minus sign, because you are technically doing 3 plus radical 6 and 3 minus radical 6. So if you put that in the calculator, you would get some decimal approximations. But to put that on a calculator, you would need to do 3 plus radical 6, enter, 3 minus radical 6, enter. Okay, so let's do the same type of thing here. So I have no constant, but I have a coefficient of 5. So I'm going to divide both sides by 5. So 135 divided by 5 is 27. So I get x plus 7 squared equals 27. Then when I take the square root of both sides, I get x plus 7 equals plus or minus radical 27, which I know I can break radical 27 into 9 and 3. So plus or minus 3 radical 3. Then I need to move the x to the other side. So So I get, or sorry, not the x, the 7 to the other side. So when I subtract 7 from the right and the left, I get x equals negative 7 plus or minus 3 radical 3. Okay, so in this one, I have a constant and a coefficient. So I'm going to subtract 6. And divide by 4. Then I'm going to take the square root of both sides, and I get x plus 5 equals plus or minus the square root of a fourth. Which the square root of the fourth actually comes out really cleanly, because the square root of 1 is just 1, and the square root of 4 is 2. When I subtract 5, I get x equals negative 5 plus or minus 1 half. So unlike all the other examples we've done today in this lesson, you can actually simplify this down. That 1 half is not a radical, it's rational. So you can break it down and say, well, x equals negative 5 plus a half, so negative 4 1/2, and x equals negative 5 minus a half, so negative 5 1/2. So those are actually your two solutions. And remember, we're talking about quadratics, so every equation will have at most two solutions. So I'm going to start by subtracting 12. That's my constant. Then I'm going to divide by 8. Then I'm going to take the square root. But the square root of 4 is clean. The square root of 4 is 2. Plus or minus 2. 1. I get x equals 1 plus or minus 2. And just like that last example we did, I know that I can add and subtract those numbers cleanly. 1 plus 2 is 3. 1 minus 2 is negative 1. So now it's your turn. Try examples A, so in example A, you get negative 2x plus 20 equals 2. So subtract 20, divide by negative 2, and then take the square root. That's the answer to example A. Now try example B. Okay, for B, 1/4 x squared plus 3 equals 15. So I'm going to start by subtracting 3. Then the opposite of multiplying by a fourth is multiplying by 4. They're reciprocals. So I get x squared equals 48. And when I take the square root of both sides, I get x equals plus or minus the square root of 48. And 48 can be broken down into 16 and 3. So x equals plus or minus 4 radical 3. Now take a second for yourself and go ahead and try C. Okay, so in C, I'm going to subtract 2. Oops. did I do over there? That doesn't make sense. Subtract 2. I get 3. Then I divide by 4. And I get x minus 1 squared equals 3/4. But I know the square root. I don't know the square root of 3, but I know the square root of 4 is 2. So I break it down to this. And then when I add 1 to both sides, running out of room, I get x equals 1 plus or minus radical 3 over 2. Okay, go ahead and try that last example, example D. So in example D, I'm going to get rid of my constant. Then I'm going to multiply by negative 5. Get rid of a negative a fifth, because negative 5 times negative a fifth is positive 1. Then I take the square root of both sides, and I get x plus 3 equals plus or minus square root of 25. But the square root of 25 is super clean. It's just 5. So my two solutions are x equals negative 3 plus 5, which is 2, and x equals negative 3 minus 5, which is negative 8.